Okay guys, now we are going to study the VSEPR theory. We have just finished the Lewis structure, right? Hope you like that. And after the Lewis dot structure, now let's study the VSEPR theory. Okay, so VSEPR theory refers the valence shell electron pair repulsion theory. Okay, what is this actually? This VSEPR theory tells about something repulsion between the electron. Okay, so what happens after repulsion between the electron? What is this? Means um, uh, what is this actually? Is this VSEPR theory? It's nothing but the VSEPR theory tells us that what is the shape of the molecule, what is the structure of the molecule, right? So till now we know that some connections, bonds, there are bonds between atoms and forms the molecule. But what is the shape of molecule? This VSEPR models tell us the shape of the molecule. And according to this theory, shape of the molecule is due to the repulsion between electrons which are in the valence shell of one atoms and other atoms. So, you know, the molecules is made up of many atoms, right? More than 2 atoms. So they have the valence shell. So the repulsion between those valence shell actually is responsible for the structure of the molecule. And this is because the like charge repels each other, right? The electron will repel each other, and these repulsions are responsible for the structure of the molecule. So the valence shell electron of an atom may be involved in the forming single bond, double bond, or triple bond, right? These last time in the Lewis structure also we see that, right? Double bonds, triple bond, these valence shell electron are responsible. But each arrangement of the electrons creates a negatively charged region of the electron, right? So because the valence shell electron creates one negatively charged region around the atom. So that charge region of the electron density around the nucleus, right? So because like charge repel each other, the various regions of the electron density around an atom spread so that each is as far away as possible from the others. So you know the repulsion, if there is a repulsion, they will try to remain as far as possible, as farther as possible, right? So because they try to go as farther as possible, and because of that phenomena, the molecule has the structure. So now let's go examples, and then you will understand. Okay, so now let's see here the CH4 molecule. Okay, CH4 molecule. So CH4, and this is the carbon, and you have a hydrogen here, this is H, there is another H here without structure. Okay, let's see what happened here. This is H, this is H, and this is C. What happens is this atom has the electron cloud, right? This electron cloud, valence shell electrons of this hydrogen creates the electron cloud. This hydrogen also have the electron cloud. This has also electron cloud. This has also electron cloud, and similarly carbon has also electron cloud, right? Look at that. There is a repulsion. This is also negatively charged. This is also negatively charged region. This is also negatively charged region. Negatively charged. These all are negatively charged regions, right? It means that these two will repel each other. These two will repel each other. These two will repel each other. These two also repel each other, right? And that's why hydrogen and this also repel, and already there is a bond, right? Because of this, there the bond. So what will happen is they will repel each other, and finally they reside in such a way that the maximum repulsion, there is no further repulsion, and they are stable, fine, no further effect, right? So this is the VSEPR theory. And what will happen, they will live as like that. Look at that. This is the tetrahedral structure. Okay, so according to the VSEPR theory, the 4 regions radiate from carbon at angle of 109.5 degrees. So how they sit down is, here is the carbon and here is one hydrogen, and then they will live like that. So this is the tetrahedral, right? This is the tetrahedron. So when they remain at the corner of this tetrahedron, then that is the stable condition. So what is this angle? That angle is 109.5 degree. So this is the most stable structure. So it's given here. So because the repulsion of the electron. So that's why shape of the methane is tetrahedral. So this is the shape of the methane. So here is the question: is the shape of the molecule is tetrahedral, or shape of the electron cloud is tetrahedral? In this case, both. But some case the structure of the electron cloud may be different, and the structure of the molecule could be different. We will go in some example, and then you will understand. Now let's see that here. So what happened here? Now NH3. Okay, so you have NH3. So nitrogen has two lone pair, right? Here is hydrogen, and here is hydrogen, and here is other hydrogen. So they will repel each other, right? So this is the repulsion here, this is the repulsion here. Here is the lone pair. Now let's write down the lone pair as a balloon structure, so that this is not really really something object, right? We just denote this by balloon. What will happen? This balloon also repel that, this balloon also repel that, right? These two electrons also repel these two, right? So what will happen ultimately, this structure will form the pyramidal structure. So what kind of the structure forms? Nitrogen, hydrogen, hydrogen, hydrogen. See, it's like the pyramid. See that? It's like the pyramid. Okay, this is like the pyramid. So if you see that, this is a pyramid. So this is like the triangular pyramid. Okay, so but if you include that if you include that the balloon, see, now you have two electrons are here. Now you have a good pyramid here. See, so it's a pyramidal structure now. So this is the pyramid. So this is the pyramid. So according to VSEPR theory, the four region radiates from nitrogen at angle of 109 degree. The electron pair geometry is tetrahedral. So see, electron pair is again the tetrahedral. See that? It's the tetrahedral. Now let's see that again. Okay, electron pair is, this is the nitrogen, hydrogen, and hydrogen. This looks like pyramid. You see, this looks like pyramid. This looks like pyramid. This is pyramid. But if you include the electron pair also, then it is again tetrahedral. This is again tetrahedral. So that's why electron cloud is tetrahedral, but the molecule is pyramidal. Molecule is pyramidal. So this happens. So because of the lone pair, the lone pair is just the electrons are inside the atom, right? But they have a cloud. This is not real structure. This is just a cloud, right? That's why if you include the cloud, it looks like the tetrahedral. But if you don't include that, only the atoms, means the molecule's shape of the molecule is pyramidal, and the geometry of the cloud is tetrahedral. So that happens in the NH3. Okay, now let's say one other example, very interesting example of the water. What happens in the water? Look at that. Water is, this is oxygen, and this is hydrogen, and this is hydrogen. Okay, it has, if you remember that, it has a two lone pair. One lone pair, let's make the one lone pair balloon here. This is one lone pair, and this is another lone pair, right? The oxygen, as if you remember the H2O's Lewis structure, you have a two lone pair on oxygen. So look at that, including this electron cloud also, again it looks like the, look at that, what it looks like now. It is again the tetrahedron, right? So it is a tetrahedron again. So this looks like that, right? It's the tetrahedron, like that. This is the tetrahedron, right? So again, this, and this is a tetrahedron. Again, the electron cloud is tetrahedral, but the molecule, just remove the electron, right? Electrons are actually inside this this oxygen. So that's why molecule is made up of two hydrogen and one oxygen. In excluding these electron clouds, the molecule looks like what? Bent, just the bent, angular. See, this is just the angle, right? This is the bent. That's why water is interesting. Water's electron cloud has a tetrahedral geometry, but its shape is bent, angular. So this is another example, right? Now let's see these examples. The shape of the formaldehyde CH2O molecule, you see that CH2O, this looks like what? So trigonal planar, you see, this is a trigonal planar with angle 121.8 degree, and this angle is 121.8, and the angle between two hydrogen is 116.5. This is the trigonal planar, and this is the formaldehyde structure. Okay. So now let's see other one. So C2H2 ethylene molecule. This looks like that. This angle is 121.4 and that angle is 117.2. And if you go from the sideway, that's why it is a planar, right? You see, it is a planar, right? Trigonal planar it is. So each carbon atom is trigonal planar. So this carbon is also planar in a one plane, right? See, it is in one plane. So that carbon also in one plane. This carbon is also, that's why each carbon is in the trigonal planar. So, and the electron cloud density also the same thing. So that's other example. Now let's see this one. This also looks like that, you see. So the Lewis structure shows carbon surrounded by two regions of the electron density, right? So you see, two regions of the electron density. According to VSEPR, the two regions radiate from each other. Carbon atom at an angle of 180 degree. The shape of the molecule is the linear. So this looks like this, the linear. So that's why this hydrogen and these hydrogens are farther away, farthest of each other. That's why this is the linear. So according to VSEPR theory. So now let's see some example. Okay. So methane molecule is the tetrahedral. Its angle is 109.5. Ammonia is pyramidal, right? Pyramidal is the ammonia shape, and the electron cloud is the tetrahedral. Water is bent, and the tetrahedral is its geometry. All these are tetrahedral. Electron cloud, look at that, predicted distribution of the electron density. Electron density is tetrahedral of these three molecules. Electron density trigonal of these, the angle is 120 degree. Okay. Electron cloud is linear of these, and the angle is 180 degree. You know, the linear means 180 degree, right? Now let's say some example. Okay. What we are looking in previously is, so in previous case, if you have a lone pair, you see, the geometry is tetrahedral, but if you have one lone pair, then the structure is pyramidal, right? Because the electron cloud is not actually in the structure of the molecule. It is just the cloud's shape is there, but the electron cloud is just the two electron inside that. That's why you just have to ignore that. So what happens is, if you have the nitrogen here and an electron cloud are here, so okay, so hydrogen, right? So this is pyramid, but if you include the electron cloud also, this is the tetrahedral, right? So that's why electron cloud is tetrahedral, and the number of lone pair is how many? 2. One lone pair. If one lone pair, it is pyramidal. Okay. Now let me show you something. Okay, nitrogen. So now the nitrogen here. So the nitrogen has one lone pair, right? Let me make the lone pair here. So one hydrogen is here, and other hydrogen is here, and other hydrogen is here. So it is, if you include the lone pair also, lone pair means 2 electron. So this is tetrahedral. Geometry is tetrahedral. This is tetrahedral, right? If one lone pair is tetrahedral, so tetrahedral geometry, one lone pair is electron means remaining is what? It is a pyramidal, right? If geometry is tetrahedral, one lone pair are only one, then it is a pyramidal. What if there are 2 lone pair? Now let's see the water. Water is H2O, H2O, right? But the water has, let me make the two, let me show you 2 lone pair in different color. Okay, so red is one lone pair is here. This is one lone pair. Okay, let me take another lone pair in the different color, green suppose. Okay, so one lone pair is here. See, these 2 lone pairs are also farther away. So if that is, you see that 2 lone pair, again the structure is tetrahedral. Again the structure is, see, tetrahedral. So electron cloud is tetrahedral, but what if you don't include electron cloud? If you don't and the lone pair is number of lone pair is equals to 2, right? One is this and one is this. If two lone pairs, then what will be the, if you ignore these two lone pairs, what will be the structure? Structure is OHS. It is the bent, right? Okay. If tetrahedral geometry, one lone pair, it is the electron cloud shape is okay. Now let's see that if the geometry is tetrahedral and the lone pair is 1, lone pair is equals to 1, then it is pyramidal structure. Pyramidal shape is pyramidal, and the geometry of the electron cloud, E cloud, is equals to tetrahedral, right? Geometry of electron cloud is tetrahedral. If it has lone pair, pyramidal shape of the molecule's pyramidal shape. If geometry is tetrahedral and the lone pair is equals to 2, then bent, the shape of molecule is bent. Shape of molecule is bent. Okay, shape of the molecule is bent, and the geometry of the electron cloud is tetrahedral. So similarly, if the cloud is trigonal planar and you have no lone pair, then it is a planar structure. And if you have two lone, that is also planar. Okay, two lone pair. So linear is linear, right? Always linear. Okay, it doesn't matter how many lone pair there are. So now let's list out something. So that's why let's see that let's forget the hybridization. Okay, guys, we are not studying the hybridization. That's why don't worry about the hybridization. So we are not discussing hybridization. So you don't need to worry about hybridization. Now let's see that. So the structure is linear. The structure is linear. If structure is linear, means electron cloud is linear. Okay, and lone pair is 0. If lone pair equal to 0, then 0 lone pair. Okay, let me see that. Okay, 0 lone pairs, 1 lone pairs, 2 lone pairs. Okay, if 0 lone pair, it's a linear, and 1 lone pair is like that, and 2 lone pair, no structure then, right? 3 lone pair, same thing. Okay, so if okay, so okay, sorry guys. Okay, that's good. Now, so if the trigonal planar, okay, if the trigonal planar 0 lone pair, if it has a zero lone pair, it is a trigonal planar. If it is a zero lone pair, okay. So and then the 1 lone pair, it is a pyramidal. You see that 1 lone pair, if you have 1 lone pair, you have ammonia, it's a pyramidal. If 2 lone pair water, it is bent, right? If 0 lone pair sp3d hybridization, then that is a trigonal bipyramidal, like that. Okay, we are not studying hybridization. That's why just think about this. 0 lone pair, we may have this structure, trigonal bipyramidal structure. 1 lone pair, we may have the seesaw structure. 2 lone pair, we may have the T-shape, and the linear, like that. Okay, but then now let's go to the another list one. Okay, so this is the VSEPR theory. So previous one is the hybridization, which we have not to study. That's why if you are interested, you can see that hybridization. And you can ask me also if you want to study the what is that hybridization. Just I have introduced it for you. So for your interest, if you have interest, you read that, and I will tell you what is that. So now for the VSEPR theory, let's see that if you have a two bonding groups and the lone pair is 0, then the molecular geometry is linear and the approximate bond angle will be 180 degree. Okay, guys. So how many? Let's see that. CS2. Okay, CS2. Okay, this is the CS2 molecule, and it has, this is the Lewis structure. Okay, so and this is the Lewis structure. So how many bonding groups? One group is this, one group is this, right? There are two bonding groups, and the lone pair is 0. Lone pair is 0. then the electron geometry will be linear. So look at that, it's the lone pair at the center. Okay, how many lone pair at the center? 0. So electron cloud geometry will be then linear, and the molecule will be also linear. And the example is this. Okay, this is the example and this is the structure. Now if there are 3 bonding groups, now let's see B, Cl, Cl, Cl. Do you see that three bonding groups? So how many? So you know these the corner atom can have the lone pairs. Okay, but we are not thinking about the corner, the center. Okay, so if the central atom has 0 lone pair, so 3 bonding group, 1, 2, 3, 1, 2, 3 bonding group, right? 3 bonds are there. Then lone pair is equals to 0. If 0 lone pair, if you see that it don't have any lone pair, right? At the center atom, it don't have a lone pair. So in this case, the structure is trigonal planar. Trigonal planar means they are triangle in a one single plane. This is the trigonal planar, right? So that's why trigonal planar, and the angle will be 180 degree. And what will be structure? So for example, BCl3, B, Cl, Cl, and Cl. This is in the one same plane. Okay, means that if it is your paper, it's reside over here like that. It's sitting like in the same paper. See my hand. If you see that my hand. Okay, so in that this is the planar in the same plane. For example, if it's the wall, this is the planar, same plane. But this is the perpendicular to plane. This is the planar in the same plane, right? So that's why in that case, like that. If you have a bonding group 2 and 1 lone pair, if 2 bonding group, for example, SO2, okay, SOO, 1 lone pair is here. So if that happens, they have also lone pairs, right? So they have also lone pairs, SO2. Where double bond means 2 lone pair, means that these lone pair will attract, repel these will repel this, and the final result will be that will repel this and try to push down, that will repel this and try to push down, right? If both are pushed down, then you have the structure of the band. So if the 1 lone pair, if you have a bonding group 4, there are 4 bonding group but no lone pair, then the structure will be tetrahedral. For example, so clouds structure also tetrahedral, molecules also structure tetrahedral. For example, you have a carbon, hydrogen, 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 hydrogen. There is no any lone pair at the central molecule. In that situation, what will happen? This will repel this, this will repel this, this will repel this, this will repel this. All repulsion there. Because of that repulsion, the structure will be like that: H, 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 and H. So this is the tetrahedral structure. You know the tetrahedron, right? So this is the tetrahedral structure. That's why if there are 4 bonding groups and the no lone pair, then it is a tetrahedral. The electron geometry also tetrahedral, molecular geometry also tetrahedral, and angle will be 109.5, and the example is CH4. Okay. So if again 3 lone pair, sorry, the 3 bonding group, bonding group 3, see bonding group 3, and the 1 lone pair, then again the structure the electron cloud geometry will be tetrahedral, and but the structure is trigonal planar. For example, PS3, right? Let's say PS3 or NH3, let's say NH3, see, NH. In that situation, lone pair is here, that's why electron cloud geometry will be tetrahedral, but the molecular same is just the pyramidal. So okay, so the trigonal pyramidal, and the angle is slightly less than 109.5. okay. So if bonding group are 2 and there are 2 lone pairs, for example SH, 2 lone pairs, H is here, H is here, then in that situation it is a bent pair, H, it is bent. Okay, so it is the bent, but the electron cloud is again tetrahedral, guys. So electron cloud is 1 electron cloud will be here, 1 will be here, that's why again tetrahedral. 2 lone pair and 2 bonded group, that's a tetrahedral. Similarly, here are the listed given. For example, if you have a bonded group are 6 and 0 lone pair, it is octahedral. Okay, it is octahedral. So if the 5 bonded group and the 1 lone pair, it is octahedral and the structure is square planar. So okay, square planar. Structure is square planar. So octahedral, then 4 bonded group, 2 lone pair, then is octahedral and the geometry is square planar. So if 4 lone pair, 4 bonded group and the 1 lone pair, then the bipyramidal is the electron cloud shape and seesaw is the molecule C structure. Okay, you can see that here. Now let's say 4 bonded group is 4. For example, 1, 2, 3, 4 bonded group are 4 and a lone pair are 1 lone pair is here. So then what will happen is, so it is the bipyramidal. Okay, it is the bipyramidal structure and the seesaw is the molecular geometry. So for example, F4, SF, it is also F, it is also F, it is also F. See, 4 bonded group, but you have 1 electron pair also here, means this electron pair will repel that also, right, and they will also repel. So in this scenario, what will happen is the trigonal bipyramidal is the so for example, S, this is trigonal bipyramidal like that. Okay, so 2 pyramids actually, so 2 pyramids are there, right? Trigonal bipyramidal is the electron cloud shape and the seesaw is like that. Okay, see, look at that here, this is, one is here, one is here. So F, 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 F. So this is the molecular shape, but the electron cloud will be like that. One electron cloud will be here, and so then you know that then it looks like that. Okay, so this is the trigonal bipyramidal. So this lone pair, it's the seesaw is its structure. Seesaw is the molecule's geometry, and the electron cloud will be the trigonal bipyramidal. So lots of examples are given here. You can see, okay, and you can see, and I have posted these on the canvas also. You can take from there. So now let's see that molecular polarity. This is the VSEPR theory. Okay, guys, VSEPR theory tells you what is the structure of the electron cloud and what is the structure of your shape. And I have the list here. If 4 bonded group, what is that? And a 3 bonded group and 1 lone pair. So how many lone pairs and how many bonded groups? It depends. If you have this structure of the molecule depends upon how many bonded group and how many lone pairs, and they are given in the list. Okay. So molecular polarity means some molecules are polar and some are non-polar molecules, right? Polar means it has a 2 electric pole. So a molecule will be polar if it has a polar bond. You know, the polar bond we have studied previously, what bond are polar and what are non-polar bonds, right? And if the bond is polar, then the molecule is polar. So if it's the center of the partial positive and partial negative charge do not coincide with the result, then one region of the molecule attains a net partial positive and the other attains a net partial negative. These are the polar. Then if it has a partial positive and partial negative, then it is molar. But it is the polar. But the carbon dioxide, if you think about, okay, now let's see that it has a polar bond, right? Carbon dioxide has this bond and that, both are the polar bonds, if you remember that, because it is delta negative, it is delta negative, it is delta positive. That's why this is a polar bond, right? Delta positive, delta negative, delta positive, delta negative. So but this, the structure is, look at that, this is dipole moment. It is said to be dipole moment in this direction, this dipole moment in this direction. That's why delta positive, delta negative, this force in this direction, this force in this, overall is 0. Resultant is 0, right? One is right hand side and other goes to the left hand. That's why if this is -5, this is +5. If you add that, this is 0. So no dipole moment. That's why this is the non-polar. However, it's a bond are polar. Okay. But if you think about the water, so you see water's structure, it has a big red here and a blue region here. Blue region is the positive region, red region is the negative region. That's why this molecule has 2 regions. One is the positive regions and other is negative region. That's why this molecule is the polar molecule. Okay. So now oxygen, hydrogen, you see. So now loss of electron cloud is pulled by this. That's why this is delta positive, and this is this is delta negative, this is delta positive. Similarly, this is delta positive. So resultant is, overall resultant is one force is like that, other force is like that. That's why resultant is like that. So it's not zero. That's why water is the polar molecule. So again, let's say one other example. Both dichloromethane and the formaldehyde have the polar bonds and are polar molecules. So yeah, so look at that, how much this one region is positive, other region is negative. It is a polar molecule, right? So delta positive is delta negative. That's why electronegativity difference, you see that the electronegativity difference tells you the polar and non-polar, right? Last time. So whether the bonds has total overall, the one region is positive, other region is negative, then it is a polar molecule. For example, CH2, Cl2, CH2O, these are the polar molecules. Okay. Now let's go further. So that's it. So in this chapter, and we have that's it. Okay, we studied the VSEPR theory and the polarity of the molecules, right? It's not necessary that the bond are polar, but the overall molecule can be non-polar if it's the linear structure. But otherwise, if the bonds are polar, then the molecule can be polar if the molecule is not linear. Okay, so total resultant force is not cancelled, then they are polar. Means that the molecule is polar if its one region is partially positive and one region is partially negative. Okay, so then that is a polar molecule, especially if you have a OH involved, chlorines like that. Okay, so these are the polar molecule. For example, S2O, NS2. If they have a lone pair, they are also polar. Okay, now I think I forgot to say you that. So now a molecule will be polar if it has a polar bonds, right? If it is a polar bond, but there are exceptions. These exceptions are carbon dioxide. Okay, however, it has a bond is polar, right? The electronegativity difference is here, but the overall resultant is zero. That's why it's not polar. Thank you so much for today. If you have any question, please ask me. And now let me revise again. We have studied the VSEPR theory. VSEPR theory is the valence shell electron pair repulsion theory. So VSEPR theory tells you that the structure of the molecule is due to the repulsion between the electrons of the valence shell. Means the how many valence electron, these valence electron repel each other and form the structure. Okay, that's the VSEPR theory. And thank you so much. And we will discuss the chapter 4 now. We finished the chapter 3. Enjoy this class, and this is up to the chapter 3. If you have any question, ask me please. Thank you.